Welcome. Today we'll be discussing section 4.2. Topics include double angle, half angle formulas. Now, I'll show this with the double angle, but really what this is just the sum difference formula with another trick, and we get another set of formulas. And we'll see that here in a second. But for now, we have sine of 2 theta is equal to 2 sine theta cosine theta, and cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Now, oftentimes we will take sine squared theta and we could substitute in the Pythagorean identity. So we get sine squared theta is equal to 1 minus cosine squared theta. Distribute the negative and combine like terms, and we get 2 cosine squared theta minus 1. And these are valid results for cosine of 2 theta. Now, you can take these two, put sine of 2 theta divided by cosine of 2 theta, and we get tangent of 2 theta, which you can imagine of just putting one on top of the other, use some trig identities, and we'll find that this equals 2 tangent theta over 1 minus tangent squared theta. And so really just take this one as the numerator, this one as the denominator, times both of them by 1 over sine squared theta, and we get 1 minus tangent squared theta. That's the denominator. Cancel. We still have 1 cosine left over. Sine divided by cosine. We get tangent. So we can recover the tangent through the double angles. However, I claimed that this is just a hidden angle difference formula. Well, let's take sine of 2 theta, and this is really the same as sine of theta plus theta, which I can rewrite as sine of theta minus negative theta. Well, we know with the angle difference formula, we get sine of the first term, theta, times cosine of the second term, negative theta, minus cosine of the first term, theta, times negative sine times the second term, which is negative theta. Now, this negative here with cosine, since it's an even function, we can ignore it, make it a positive. And this negative here with the sine, well, we can times by -1 on the outside to make that positive. And now we have the addition of two same terms. Combining them, we get 2 sine theta cosine theta. And we recovered the identity. So for your check on learning is I want you guys to work out how to get cosine squared theta minus sine squared theta with the cosine of 2 theta. I'll write out some of the steps. I want you to include justification for each step. So it would look like this. Start with cosine of 2 theta. And this is equal to cosine of theta plus theta, which is equal to cosine of theta minus negative theta. So same step as the sine. Now we have cosine of theta minus negative theta is equal to cosine of theta times cosine of negative theta plus sine of theta times sine of negative theta. And this is because of the angle difference formula. Now we take this and we have cosine of theta times cosine of theta, because cosine is an even function. And here we're going to have negative sine theta times sine theta, because sine is an odd function. Combine like terms, and we get cosine squared theta minus sine squared theta. And so we have cosine of 2 theta is equal to cosine squared theta minus sine squared theta. I want you to write down these steps and include a justification of why each step is done as your check on learning. So let's see some examples of questions utilizing these formulas. So we're going to let theta be in the third coordinate and cosine of some alpha is equal to -5/13. We want to find cosine of 2 alpha and sine of 2 alpha. That's what we want to do. So the first thing to know is that we're in the third coordinate or quarter. And so that means that on the graph, we're over here in Q3. And so what this means is that in quadrant 3, both cosine of an angle in here and sine of an angle in here are negative. So that's just something to note. Now we have cosine of 2 alpha is equal to, and we don't know what sine alpha is, but we know what cosine of alpha is. So we want to have 2 cosine squared alpha minus 1. So we're going to take cosine alpha and square it. So that means that we have 2 times -5/13 quantity squared, and we're going to subtract 1 from that. So that gets us positive 25 over 169. We're going to times that by 2. So we get 50 over 169 minus 1, which then this equals -119 over 169. So now for sine we have sine of 2 alpha is equal to 2 cosine alpha times sine of alpha. So we know what cosine is, but we don't know what sine is. However, we know that cosine squared alpha plus sine squared alpha must equal 1. So we can plug in negative 513. So we have 25 over 169 plus sine squared of alpha is equal to 1. Subtract this to the other side, and we get sine squared alpha is equal to, and 1 minus 25 over 169 would be 145 over 169. Oh, sorry. No. 144 over 169. Take the square root. And this is where it's important that we're in quadrant 3 because we want a negative answer. So we have sine of alpha is equaling negative 12 over 13. So we can substitute that into here. So we have negative 12 over 13. Here we have negative 5 over 13. And here we're going to keep the 2. So now our negatives cancel. Our 13s times by each other. So we get 169. And so now we have 2 times 5, that's 10. 10 times 12, so 120. We don't have to reduce because we have 13 squared, and 13 is not a factor of 120. And so that is our answer for sine of 2 alpha. And for completion, cosine of 2 alpha is equal to negative 119 over 169. So now let's discuss the half angle. Now, it might look a little weird, but you can think of it as if we can somehow solve one side in terms of cosine or sine, we kind of half the angle here. So for my half angle, formula, let's start off with cosine because I think that's the easiest to see. We're going to have plus or minus the square root of 1 minus cosine theta all over 2. And where we can see this is that we're taking a square root and we can, sorry, this is plus. And I won't drive it, but we could start from here and start maneuvering items to get the cosine by itself. And that's effectively making this be half. So if I add 1 to the other side, divide by 2, and then take the square root, I generate this. And so for sine of theta over 2, we're going to have plus or minus square root of 1 minus cosine theta all over 2. And for tangent of theta over 2, we get plus or minus square root of 1 minus cosine theta all over 1 plus cosine theta. So in a similar fashion, you can see that this tangent is really just sine of theta over 2 divided by cosine of theta over 2. So let's get an example of using a half angle. Before I do that, let's do some notes, some guidelines on how to answer it, because this is a little bit tricky because we have the plus or minus. So if theta is somewhere between 0 and pi over 2, then 0 is less than or equal to theta over 2, less than or equal to pi over 4. And so basically what this means is that if we're in Q1 or the first quadrant, we're going to stay within the first quadrant. If theta is between pi over 2 and pi, then we have pi, it's somewhere between pi over 4 and pi over 2. So what this means is that this is in quadrant 2, and when I take the half angle, my theta is now in quadrant 1. If theta is somewhere in between pi and 2 pi, then we're between pi over 2. Oh, this is theta over 2. Theta over 2 and pi. And so here, if we're in quadrant 3 or quadrant 4, we become in quadrant 2. Now, this isn't, it shouldn't be that surprising, but it's good to keep track of. So we know where we're landing and we can keep track of whether our cosine is positive or negative. So let's see an example now. We have, let's theta be between pi and 2 pi. And cosine of theta is equal to -3/5. And we want to find what the half angles are of sine and cosine. So we want to find cosine of theta over 2 and sine of theta over 2. So since we're in between pi and 2 pi, we now know that we must land somewhere in quadrant 2. So in quadrant 2, we can think that that's here, which sine is positive, but cosine is negative. And that checks out because cosine is negative here. So we can now write sine of theta over 2 is equal to plus or minus the square root of 1 minus negative 3/5 all over 2, which we look at our chart and we see that, oh, it must be positive, so we're going to get rid of that negative. And so we're going to have positive radical. This negative distributes and becomes positive, so we have 1 plus 3/5, so that's 8/5 divided by 2, so we get square root of 4/5, which is equal to 2 over square root 5. And that's our answer to our sine. Now, cosine of theta over 2 is equal to, and we see that that's negative square root of 1 plus negative 3/5 all over 2, which that is 2/5 over 2. So we get negative square root 1/5, which we can rewrite as negative 1 over square root 5. And there's our answer. Okay, so let's do a couple more examples. So this time, we want to find exact values for sine of pi over 8 and cosine of pi over 8. So we may look at this and go, God, what do I want this angle to be? Well, we want it to be pi over 6, pi over 4, pi over 3. We know those. Well, what factor can we pull out of this? We can pull out a 1/2 and say that pi over 8 is equal to pi over 4 times 1/2. Well, timesing by 1/2 is the same as dividing by 2. So we can write sine of pi over 4 divided by 2 is equal to, and we look and we see plus or minus square root of 1 minus cosine theta over 2. What's our theta? Our theta is pi over 4. Now, here's where we have to ask ourselves, where does this angle lie? Well, my original angle lies in, this pi over 4 lies right here. So that's in quadrant 1, meaning that if I take half that, I'm still in quadrant 1, so I'm here. Meaning that my cosine must be positive. So I have 1 minus cosine of pi over 4. Well, pi over 4 is square root 2 over 2. So I have this being equal to square root 1 minus square root 2 over 2 all over 2, which through some simplification, I can get this to equal square root 2 minus square root 2 all over 2. That is 2 minus radical 2 all over the square root, and then I divide that entire thing by 2. So now cosine of pi over 4 divided by 2. We're going to take the same steps where we know we're going to be positive because we're, again, in quadrant 1. And now we have square root of 1 plus cosine of pi over 4 all over 2, which through simplification, we get that to be the square root of the following quantity, 2 plus square root 2. And then we're going to divide that entire thing by 2. Okay. So let's do one more example. And this time we're going to combine some expressions to make interesting equation. So we want to solve sine of 2t minus sine of t is equal to 0. So we want to use our double angle formula and rewrite sine of 2t as 2 sine of 2t. Oh, sorry. 2 sine t times cosine of t minus sine t equals 0. We can factor out a sine t, and so we get 2 sine of t. Oh, let's leave this 2 inside. So sine t times 2 cosine of t minus 1 close parentheses is equal to 0. So we have 2 cases of sine t being equal to 0, or we have 2 cosine t minus 1 equals 0. So let's start with the first one. Sine of t equals 0. Well, that means that t equals sine inverse of t, which then that is just t equals k pi or n pi. Just note that k is an integer, where k is an integer. You're never wrong to include that when you have variables like k or n. It's implied, but it's always nice to have that. Well, or we can have 2 cosine t minus 1 equaling 0. So we solved one side, and it wouldn't matter what this is because we have 0 times the number. But now we want to find where this makes 0, and it will be times by a number. So we have 2 cosine t minus 1 equals 0. Well, we want to solve for cosine t, so we're going to add 1 to the other side, divide by 2 to the other side, And we're going to have cosine of t equals 1/2. So we're going to have cosine of, we're going to have cosine inverse. So t equals plus or minus cosine inverse of 1/2 plus 2 pi n. Again, n is an integer, kb is an integer. The reason why that I'm not reusing k is I want to show that these two values could be different. I'm not saying that they both have to be k. I'm showing that, well, this one could be any integer. This one could be any integer, but they don't have to be the same integer. If that makes sense. So now what is cosine inverse of pi over 2? Well, that is pi over 3. So we're going to add a plus or minus in front of that. Then we're going to add 2 pi n. This is equals t. So I'm going to add where n and k are integers. So either one of these cases can happen. Note that here we have hidden another solution set because it's plus or minus. So we have positive pi over 3 plus 2 pi n and negative pi over 3 plus 2 pi n. This is just a shorthand. So with that, that covers all content in this video. Again, I think it's very important to see that the double angle is really just the add sum formula, just a special case of it. Very important special case of it, and we get a lot of utility. But as long as you know one trig identity, you're able to discover the rest. And that is a very important skill to be able to see the different identities within each other, and that it just is the same identity, different form, and or a special case. So as a reminder, your check on learning is to derive this equation using the angle difference formula. Thank you for watching and have a great day.